So thank you very much and enjoy the press conference. Thank you.
Well, thank you for giving your precious time for us. We really appreciate it. So today we're going to present how water changes into energy. This is the technology that's first announced in the world. In the 20th century, we all thought that water was H2O, and water has not been the center of focus. However, in water and environment, that has been our theme, and we have studied a lot and we've made research into water. And we think that instead of petroleum, we can use water, and hydrogen burns with our water, and we can take out hydrogen gas out of it. And I think we are really happy to present you this technology that is really helpful for the 21st century. So, first of all, what is water? The atomic number is 1, the hydrogen. How did the water generate, and how important is water for us? First of all, Professor Otsubo, he has been researching water for many years. And so let us first have some time to talk about what water is, how was water generated in nature, and what is the position of water in nature. And then we'll talk about the technology that we developed. I will show you an experiment also. So Professor Otsubo, please. Hello, my name is Otsubo, and my expertise is biochemistry. And water is a water that flows in our body. That's my research topic. So what is water? About 300 BC, Greek philosopher Thales, he said that water is the source of everything. Everything is absorbed by water. Everything started from water. So that was a definition of water. That was his philosophy. This definition of Thales has been alive even today. There has not been any technology that exceeds his philosophy. So in US, I think US is about 10 years ahead of Japan in measuring water. In Texas University or Georgia University or in the former Soviet Union, they were advanced in water studies. So we got cooperation from those people, and we started the research of water. And what we found out today is not much, but I'll just give you the conclusion. The essence of water is energy. And this has been backed by a lot of resources. For the experts, it's already a known fact. Water, how was it generated? Let me just talk about that briefly. Please look at this slide. At the top of this triangle, it's the start of the Big Bang. So water was generated around this period when the space expanded, plasmatic cosmos, not really yet. And 300,000 years ago, here the proton was generated. So that was really the source of everything. If we didn't have this proton, we wouldn't have all the elements, or we wouldn't be alive. Now we're here, and the evolution of the space all evolved from water found, but nobody has received a Nobel Prize for the research of water. That's how much we don't know about water. This hydrogen atom, this is the start of evolution, but it took about 400,000 years yet for the water atom to appear. Proton and the electron, those are the center of the energy of water. So the hydrogen electron and the oxygen atom that was generated in the order of eighth, they move at 8,000 kilometers per second. And oxygen moves at about half of that speed. And they collided in the space, and that resulted in the detonation reaction, and they were contained in the inside, and that resulted in water.
So water is energy. Big Bang means that the plasma energy itself, in actuality, it did not exist. Then how did it convert into water? That is something in the astrophysics that will be the area most studied in the future. So let me move on. And therefore, the water will be, broken down. This was also announced previously, but it's always said that water falls down over the earth, and some of it comes from space. Here we have the black spots in the sun. When you look at the black spots in the sun, you might think of something that affects our Earth's climate very much. But one spot is about the size of Earth. What do you think this is? This is ice. The temperature is very low. That's why it looks black. But based on our common sense, the sun seems to be like one solid matter, right? But that's not the case. It's a gaseous matter, and the surface has 6,000 degrees. Closest to the Earth, it's 6,000 degrees. And on the surface of the sun and these black spots, there is a distance between them. It's an unimaginable distance. In actuality, there are more black spots. But these black spots are the source of the sun's energy. That's the water molecules. And so, based on the enormous reaction from the sun, it acts like a gas burner. And then it creates this nuclear reaction, and then it emits helium to become 6,000 degrees. So this is several tens of billions of kilometers away in distance. Then I'm surprised you knew that this was ice. Yes, it is ice. Because even the sun was created by water. Represents is the famous Einstein's E equals mc squared. I'm sure you're all familiar with this formula.
So the right-hand formula, that is the mc square, and on the left hand is the substance. So water changes into matter and sometimes into energy. So the essence of water is energy and also substance. So this is a relative theory of Einstein as well, I think. Let me just summarize. So I said water's essence is energy. To say that in other words, when water is generated, there's going to be a lot of energy generated as well. And on the other hand, when you destroy the molecules, you also need a lot of energy. So water is made, water is destroyed. That's what our body is doing all the time. Well, Professor has talked about the water, and I am going to talk about the Sosesi water, and I'm going to show you an experiment. This experiment is something that people think is impossible. But you see, it is possible, and I'm going to show you it's possible. And I'm going to talk about what water is like. Or we started from the introduction of water. So people thought water was just H2O. However, we were saying that water is also H2O3 minus. At Tsukuba University, they generated H2O3 minus hydroxin ion by rotating water around a rock called tourmaline. And at Tsukuba University, they rotated water around tourmaline, and they found out that hydroxin ion was generated. But this was not easily believed. And at the same time, in United States, Professor Tuckerman at New York University, he discovered that H2O3 minus existed as hydroxin ion. He reported that in Science magazine, and I was very happy. I actually applauded him. So water is sometimes H2O3 minus, and the angle, the hydrogen and oxygen's angle is 104 degrees, but sometimes that angle changes. And when the angle changes, well, the pyrolysis is about 3,000 degrees to change the angle. But by changing the angle, the hydrogen and oxygen separates, and that changes into energy. So that's what we have proven. So I would like to show you an experiment. Well, in order to generate hydrogen gas, there is a methodology called steam reforming. You add heat to some petroleum, and you also extract steam vapor from water, and you take out hydrogen gas. But you have to use the petroleum oil to do this, and so you are also emitting CO2. But if you use some heat source and you make a steam, you can extract hydrogen gas. But what I did was, I mixed water with oil and made emulsion. By just adding some heat, you can generate hydrogen gas. This is hydrogen. It says 4.5. So oil and water, they are mixed at 20 to 80 ratio, and you put 5 atmospheric pressure, and then you get hydrogen gas. But you don't need to warm it. You just need to add water and oil, and with pressure you get hydrogen gas. What happens is, In the burner, you see when the emulsion is extracted, there is hydrogen. So if you put fire, the hydrogen is burning. If only hydrogen is burning, the temperature is low. But if you add oxygen, it's going to be quite high temperature. With only pure petroleum, it's about 1,200 degrees. But if you have oxygen, there's going to be several thousand degrees. And unless it's going to be more than 1,500 degrees, it won't melt. I'm going to show you a picture of this experiment.
This is a steel plate, and then you burn it with heavy oil, 100%. And then with emulsion, you get the hydrogen gas, and then you put the three plates together, and then it's like a large welding machine that was created with oxygen and hydrogen. So you can create a boiler with 3,000 degrees centigrade. That means that the water burns and it creates the hydrogen energy. This is proof of that. And then these steel plates, this is shown by magnets. So you put the three of them together. There's one on one side and another on the other side, and then the original oil has one, and then right on the left-hand side is the emulsified version with 40% water. And on the left-hand side, you see the steel plates melting because the temperature is very high. So, thank you. When the hydrogen gas is emitted, we were a little bit wondering if it was really that easily emitted, and based on the water quality, it might differ. And therefore, at the Defense University, we collaborated with a professor there to do this research for over a year. In one box, in the capsule, we would put 50% water, 50% oil, and then it would be exploded by electricity. And then with the heat conductivity, we will measure how much calorie there is. With oil 100%, it might be 40,000 calories. But if you put 50% water, the water doesn't burn, so then it goes down to 20,000 calories. That's how it should be. But with this sosesui, it goes to 30,000 or 35,000 calories. That's unthinkable. So we tried it with other water, but with other water, it's either 0 or below 0, because water erases oil. But when we use it with emulsified version with sosesui, then 30 or 40% extra heat is emitted. And so the professor said, this is something wrong with the way you are doing the measurement. And so he said, let me do the measurements. And so the professor came in, and he went to public labs to do the experiment, but he always got the same results. So he said, oh, well, I guess I give in. I'll have to concede this. And therefore, he said that as a researcher, I would agree to this. And so based on this research, he gave a lecture recently. And this is the video. The blue portion explains.
I have been taking direct measurements of Fukai green emulsion for approximately 2 years.
どういうふうにやったのかというと、深井さん
The heavy oil created at Mr. Fukai's company is referred to around the world as gas oil.
重油、これ世界的には軽油なんですが、その軽油を
I simply use a bomb calorimeter to measure the amount of heat generated from a mixture of this gas oil with water.
いうことでございます。で、その時に、水と
The blend ratio of water to oil is prepared and measured in 4 separate
書いてありま
cases.
すように、水が 30%
Case 1
で
is 30% water and 70% oil.
ケース
Case
2
2 is 40% water and 60% oil.
60
Case 3 is equal parts water and oil.
半分半分。ケース 4
And
は
case 4 is 60% water and 40% oil.
この4つのケースについてですね。
After testing a variety of methods, my recent measurements have finally indicated a method that provides the most accurate results.
いろいろやった末に、現状で最も、確かな方法だ。
It is these results from the current method that I would like to share with you now.
現在到達している方法で、測定したという結果をこれでお話しいたします。どんなふうな試験装置でやったかというと、熱量
The
計は
testing apparatus used for the measurement of generated heat is a bomb calorimeter.
計測ができるもの
This apparatus provides automated measurements.
これがビーカ
This
ーの
process involves simply using a stirrer to mix the water and oil inside the
攪拌機
beaker.
でただ混ぜてるだけです。で、これはこの中から
This pipette is a tool for taking samples.
スポイドです。サンプリングツールですね。それでこちらがこのエマルジョンを
This capsule holds the emulsion sample to be measured.
このカプセル
Normally, this much sample is not placed inside a capsule, but was done so in this case only to make this illustrative photograph.
こちらが蓋で
Next, this lid is placed on the capsule, and then the capsule is placed in the calorimeter for measurement.
いう方法です。で、そういうふうにして測定した結果が
The results of this measurement are shown on this graph, where the vertical axis shows the rate of increase in heat
発
generated.
熱量の増加率なんですね。深い
Fukai green emulsion involves a steam reforming reaction between water and heavy oil.
水蒸気解質という反応を起こします。それによって
In this reaction,
オイルが
the
持ってい
heat
る
generated
発
by
熱
the
量より
emulsion is
エマルジョン
greater
の
than the
発
heat
熱量
generated by the
が
oil.
大きく出てくるんですね。で、それを測定
This is what is
したわけ
measured.
です。ですからこちらは
Therefore, the results show the percent increase in heat generated over that of the base value for the oil.
ことを示しております。ここは 1.1 倍 10%
The coordinate axis indicates a result of 1.1, or a 10% increase, a 20% increase, etc. The horizontal axis indicates the ratio of water in the emulsion.
0.3 というのは
0.3 indicates 30% water.
0.4 というのは
0.4 is 40% water, etc.
で、この1のところの
The
赤い
red line at
書いてあるのは
1
これは
indicates the heat generated for gas oil only.
の発熱量だったら1っていうところになるというそういうことを示しております。で、ここでもう一つ
There is also one
曲線を
more
書いてあるんですけ
curved
れども
line here.
これはエマルジョンの中に
When
含
the
まれてい
hydrogen
る
of the water in the emulsion burns,
の
there
水
is
素
an increase in the heat generated.
の実際は水素の発熱量が燃えていわゆる発熱量が増えていくわけですけれども、その
This line indicates the scale of heat generated by the emulsion when 50% of the hydrogen in water burns.
エマルジョンの発熱量の倍率なんですね。この線は40%。
This line is 40%, and this line is 10%.
これは別の
Looked at a different way, it shows the rate of reaction for water as 50%, 40%, 10%, etc.
10%というのを参考までに入れてあるわけです。それで実際に試
When
験をす
actual
ると
testing is performed,
先ほどのエマルジョン
it is
は
very difficult to get uniform results
この
for a given
こ
emulsion
の混
mixture.
合というのはなかなかどこでも均一になっていません。それからこんな細い
In
スポイト
addition,
で
since this small pipette can take a sample of only 0.5 grams, the blend ratio of water to oil will vary significantly depending on the location where the sample is taken.
その結果
As a
発熱
result,
量は
there
例え
will
ば
be variations in the measurements for heat generated,
40%
as shown
のところ
here
なん
at
ですけれども
40%, for
こん
example.
な風にこうばらついてくるんですね。その平均値が
This is the average value.
これ 30% のところはちょっと
There is no data
デー
at
タが
30%
出てないんですけど
because only a few
この
points
場合
were
だけは
sampled in
数
this
点しか取ってな
case,
くてそれは
which
この辺に
resulted in the concentration of points in this
50% の場合
one
は
particular
こんな風に
area.
あの
At 50%, the values are
平均
dispersed
値を
as shown
それぞれ
here.
取っていく
The
と
average result for each
こういう
shows a reaction rate
約
of approximately
50% の
50%.
反応率の線上にこう並んでくるというのが分かったんです。で、こういう結果が出てきたので、
These results led us to conclude that steam reforming
水蒸
occurred.
気回数が起こっているというふうに考えておりまして、今後は
Therefore, we will continue to make modifications to our methods in order to find a way to measure the generation of heat without the amount of dispersion shown here.
あんま起こらないような方法で発熱量を測定しようと思っております。で、この結果でいきますとね、60% 水
These
が入っている
figures
場合
show
は
that a ratio of 60% water results in an approximately 27% increase in heat generated. In other words, this is equivalent to a 27% fuel
節
savings.
約っていうことが起こるわけです。というと世界中の油田が
If all of the oil fields in the world were to use
約3
emulsion,
割ぐらい
reserves would increase by
いう
approximately
話に
30%.
なるわけで、非常にこの技術が有効に使えば
Therefore, if this technology is used efficiently,
石油資源
it will dramatically
の
extend the life of our oil resources based on a simple interpretation of the results measured.
これは、まあ、測定結果をただ羅列しただけです。で、この深いエマルジョンに関しては、まあ、当初は
In the beginning, nobody expected Fukai green emulsion to produce such
予
results.
測はしてなくて、ずっと計測をしていく。
We simply continued
それ
to
で
take
いろんな問
measurements,
題が起こってきて
solve
それでようや
various
く
problems as they arose, and in the process, the contours of Fukai green emulsion began to take shape.
我々は、まあ、こう捕まえることができたという状況です。で、今捕まえた
I believe that the outline we see of Fukai green emulsion at this time is nearly complete.
ですからそれをさらに
That is why I want to work to develop it into something more
それ
firm.
してそれを
Once we have achieved that,
利用する
we will be able to develop a variety of devices that use it in very specific ways.
というふうにしていきたい。水蒸気回数っていうのは石炭、まあ、石油
Although both petroleum and coal can be used for steam reforming,
水と
reaction with water is possible at slightly high temperature.
水と反応させる。その時はまあ触媒がいるんですけど
This requires a catalyst, such as methanol, gasoline, or gas oil,
ガソリンでも
producing hydrogen as a result of reaction with
そういう
steam.
ようなものを蒸気と反応させると、まあ、水素が出てくると。だから、 燃料電池なん
Fuel cells use steam reforming to generate hydrogen.
は水蒸気解質を使ってるんですね。それでそれの
The reaction rate is said to be about 50% for water.
その反応率がどうも聞くところによるとだいたい 50% ぐらいなこのいわゆる反応率水の反応率が 50% ぐらい。そうするとこの実験結果も 50%。
The results for this experiment also remain very close to 50%.
だから、現状では燃料電池
Therefore,
いわゆる
I believe it is safe for us to conclude at this point that the reactions occurring in reformers, such as fuel cells, are basically the same as the reaction from the combustion of Fukai green emulsion.
じゃないかと思ってますけどね。
これは要するに水蒸気爆発ですね。
Okay, so that means that the steam explode. It's similar to a volcanic eruption, right? And petroleum also cannot be created without water. It needs the single hydrogen. So this is O and H, oxygen and hydrogen, that were separated. Why does it explode? Well, as I mentioned earlier, there is a lot of energy in Sosesui, and so the O and H already have energy, and they're easily soluble. And so even without emulsion, it already has those characteristics. And therefore, we talk about the properties of Sosesui, and we've distributed a paper which I want you to read later on. But one thing that is clear is that water, up until now, had been an
there is ion product, and usually the normal water is 10 to the minus 7th power, and it was the existing notion was this would not change. However, as you break the molecules, this ion product changes to 12 and to 11. The angle of the water molecule also changes. So this kind of really magnificent reaction takes place. So why would water and oil form an emulsion? Because water is oxidized hydrogen, and the residue of the combustion is what is water. However, if you put energy into this, then the water begins to change. So the only difference is the carbon or hydrogen, oxygen. The exhaust gas, the NOx or SOx or CO2, they are quite close to zero emission, could be. So theoretically speaking, of course, as I think Sosesui water should really be an alternative source of petroleum. Okay, let me talk about this energy. This is our challenge, and this is the biggest point in today's presentation. Well, first, I would like you to know the current hydrogen gas. What do we have? The ways to generate hydrogen gas, one way is steam reforming, or another way might be electrolysis. So you need a big plant. And also, you have to transport the hydrogen gas. You need a tank. So liquid and fuel, what's the difference? There's calorific difference and the volume difference. But you need to put the hydrogen gas at about 300 atmospheric pressure to 500 atmospheric pressure. That's why it's dangerous. Hydrogen gas itself is not dangerous. It's lighter than air. It could bond with some other gas and become dangerous, but otherwise it's not dangerous. So the hydrogen gas, in order for that to penetrate as next generation fuel, you should not be using big station. You should not be using tanks. If you can use it where you're generating the hydrogen gas, let's say in household or in car, then you don't need to transport the gas. For 20 years, I've been participating in Japan's hydrogen academy, and I've been listening to professors report at these academic meetings. And they haven't really made research into extracting hydrogen gas from water because they just think that maybe there's only steam reforming. And there are a lot of ways to there are a lot of researches on the transportation of hydrogen gas. But I think it's easy to extract hydrogen gas from water.
You need more than a temperature of 3,000 degrees, so it was considered impossible. But when we change the quality of water, then at 100 and 150 degrees, you can get the hydrogen gas. That's what I am thinking of. And as an entry point to that, Toyota and other Japanese companies are studying this matter to get the metal as the catalyst. And then you would have a reaction with water to get the hydrogen gas. Let me introduce that to you. And the other thing is, this is in Muroran, Hokkaido. There is a Muroran Technical Institute that is doing this. And here they use aluminum. Activated aluminum or activated magnesium is the format that they are using. And then they get it reacting with water to get the hydrogen gas. So aluminum or magnesium powder is frozen. And then by warming it up in an instant, the powder cracks, and then the water goes in, and then you can get the hydrogen gas. The problem with this method is per 1 kilogram of activated aluminum, it costs 1.5 million yen. The Toyota case also, for 1 kilogram, it costs maybe, I don't know, $1,000, $2,000 or something like that. And then you apply heat and do various things to it, so it's very costly. And so as shown here, the alkaline ion product and water has a reaction, and you get 17%. And there's a small amount of hydrogen gas emitted, but it stops there. What this means is that water covers the aluminum and creates a membrane, and so then the reaction stops. That's the disadvantage. But when you change the quality of the water, then even without processing the aluminum, you can get the reaction till the end and obtain the hydrogen gas. Here, I'm drinking this right now, but this water that I'm drinking, we have the hot water here. This water, the first time we use the reaction using hot water, but then after that, it doesn't have to be hot water. It could be just a regular water without being heated. And by adding this water, the hydrogen gas is continuously emitted, or you can stop it. So I'm going to show you an experiment.
So normally the aluminum reacts in such a way. For 1 gram, you get 1.24 liter of hydrogen gas. That's what people say. However, by changing the water quality, we can get 2.7 liters of hydrogen gas. That's about twice as much. So now I'm going to experiment. This is aluminum powder. This is magnesium powder. This just costs $1 or to about $5, $1 to $5 a kilogram. Because you see, you can just make a powder out of recycled aluminum can. Here, magnesium also. Yesterday, we took some hydrogen gas, and here's some residues. This is the key to our method. What we have from the residue, because we only use water, the residue is 99.9% aluminum hydroxide. So aluminum hydroxide costs about $10 to $60 a kilogram. So you can extract something that is much more expensive than your raw material. This is what we're putting into the water. Oh, sorry. This is the aluminum hydride that is the residue. So 99.9% aluminum hydrate, that is what can be extracted. This is about 40 micron. The aluminum hydroxide, this is sold at about $5 per 500 grams. And this aluminum hydroxide is used as insulator or pharmaceutical material, and it has a lot of use. And it can be sold at about $50 per kilogram. So you can sell what you get, the residues. In Iceland, they have so much aluminum, they use hydrogen gas, so they can use the residues, they can sell all the residues. Okay, now I drank the water or I put tea. I just want to show you that only we're using water. So now we put some soap water here on this side because hydrogen gas is so light, it just raises up. So we want to contain the hydrogen gas in the bubbles, and then if you put the fire nearby, it will combust. Okay, there's another experiment. This is magnesium. Inside sosesi water, we can put the citric acid. Yes, you see, you can just add a little bit of citric acid and it even burns better. So you see, there's a lot of hydrogen gas coming out. You can use this hydrogen gas for fuel cell, or if you add the oxygen gas, it becomes at about a temperature of 2,000 to 3,000 degrees. So you see, by changing the quality of normal water, you can extract a lot of hydrogen gas. If you put hydroxide, then you cannot extract the aluminum hydroxide. But since ours is 100% water, we can extract aluminum hydroxide as well. You don't need to use bauxite and caustic soda to decompose. You can just manufacture aluminum hydroxide this way. That's all because this water is different. It includes hydroxide ion, and ours is not a heavy water, but it's close to heavy water. That's why this kind of reaction occurs. In the beginning, there were some oxygen, so But if once this becomes 99% pure hydrogen, then it just is quiet. There's a quiet combustion. You can just add water into this, and the hydrogen gas keeps generating. And let's say for electric vehicles, one charge is 100 kilometers running, but in the winter, you have to get some heat, air conditioning, so the car would only run for 70 kilometers. But with this one, if you just keep on adding water, it will run for 10,000 kilometers. And you can also use this heat for air conditioning. In the household, you can also do the same. Here you can feel this is very hot, so this heat can be used to boil your bath. Come up here and please try to touch how hot it is. This is about 90 degrees centigrade to 100 degrees. So by using hydrogen gas, generate hydrogen gas, and you can get heat, and also you can sell aluminum hydroxide. This you can recycle this residue. You can sell it at a high price. So what do you think will happen? You can imagine. I think all the electricity poles, we no longer will need that because we can use this energy. And you see, let's say this is aluminum can. Aluminum can is really a source of energy. So this is just a container now, but aluminum is really electricity inside. There's electrolysis of bauxite. So we shouldn't throw away the aluminum can because it contains energy. We can get electricity out of aluminum. Hydrogen gas just raises up, so if you do it upside down, that's hot.
So the H3O2 minus, I was initially criticized about this, but what gave me a lot of encouragement or courage was someone that I had never known before, Dr. Tuckerman's announcement about this H3O2 minus. And so I was so happy to hear that that does exist, H3O2 minus. So I have been lecturing about that. By changing the angle of the water, this kind of thing can be created. And then in the future, how will we proceed with this? That's what we want to consider from now on. So I want to get a pure hydrogen gas, and then it can be used in nuclear fusion, and we would no longer need small nuclear reactors because we can move airplanes or ships with this. That is how I am feeling. So if possible today, and Dr. Tuckerman did some water analysis. So we asked Dr. Ogawa, and got permission to do a similar analysis. This is quite difficult for me, and I don't understand everything, but it shows a different reaction from regular water in all cases. So if you have time, and if we have time, we really would like to do that later on. Okay, then we don't have that much more time, but let's get started. This water itself if you put water in the washing machine, you put detergent in it, and then you turn on the washing machine. It turns round and round for 40 minutes or so. If you don't put in the detergent, you can't get it cleaned. So it has been thought that water and oil do not mix, but it does mix. Just by shaking it like this, you can see the emulsifying action. And then you see bubbles on the top. So that portion has a mixture of water and oil, as you can see. That's why it can be mixed with heavy oil without any, surface activation substance in it. So the explosion will not occur. And so the elasticity on the surface is maintained, and then it can be exploded and water and oil can mix. So what does this mean? That means when you look at the environment hormone, phenylethanol, you don't need to use those kind of activation triggers. So that means that in Japan, there are people who live without using detergents. For example, in restaurants, you would use the dishwashing detergent, right? But even if you don't use any detergent, just by using this water, you can get the plates clean. And when you make soup with this water, it's very delicious. And in hot springs, in the hotels or inns, then they don't provide you with any shampoo or conditioner. They said, please don't use it and just wash your hair with this water. That's what it says in these inns. So this is very environmentally friendly. It doesn't pollute the water. That is the starting point. And so many people are making use of sosetsui water in that way. In a coin laundromat, maybe it takes 40 minutes for one cycle, but with this kind of water, it takes 15 minutes. Without any softener or without any detergent, that kind of coin laundromat is increasing in Japan or in Taiwan. The clothes become very clean. And so in a regular household, you can avoid using detergents, dishwashing detergents, or shampoos and conditioners. You can just live using this water. Any kind of dirt can be removed with this water. And therefore, the wastewater in a household is very clean. And if you take a bath with this water, then this sosetsui water is very reductive, and so people with atopic dermatitis can see their skins peeled. So at Kanazawa Medical University and at other medical schools in Japan, this water is being studied to see if it can be used for cancer or diabetes. And therefore, it's very popular as drinking potable water. But I don't intend to use water to make business. I just do it voluntarily, just charging for a shipping. But what I want to do is to promote the water. Just by adding this equipment to the metering equipment, then it will be very good. It's environmentally friendly. So people who sign up for the equipment they have to sign this promising statement, affidavit saying that they will not use any more detergent. Otherwise, we do not install the equipment. And so, under those circumstances, now we are talking about generating the hydrogen gas for power generation, self-generation. Whether it be night or day, or summer or winter, you can generate your own electricity. We want to create that kind of a world. That is our dream. And therefore, the water and oil will mix. It will be environmentally friendly. So this can be used in agriculture without any pesticides, for example. And so the amount of crop generated is very good. So agriculturally and chemically, this has all been proven. Why does this happen? That's all been proven. So we are going for multifunctional use for Soseisui water.
This is Soseisui water. So at about 100 degrees, just over 100 degrees, 181 degrees, you put 10 atmospheric pressure, and then you can get hydrogen gas. This is 182 degrees, 10 pressure, you get hydrogen gas. So just with few atmospheric pressure, the heat disassociates the molecules. This is the first in the world, I think. So 100 degrees centigrade is quite low, and you can extract hydrogen and oxygen. So with the solar rays or the solar light, you can actually get the same result. You don't need any catalyst like aluminum. Do you really get what I'm saying? Only at 100 centigrade, that's the solar ray temperature, we can separate water into hydrogen and oxygen. We don't need any catalyst like aluminum or magnesium. So I think this is for the future, but we'll see that will happen.
Now is time of a question and answer. So of course I'm sure that you have a question. So we are very happy to answer that.
So I appreciate what you guys are saying here today. What I don't see in the presentation is any reference to peer-reviewed publications. Usually the process in science is, not to have a press conference like this, but to publish results in peer-reviewed journals so that it goes through the filter of the scientific community. So can you tell me what results you have that have been published in the peer-reviewed literature, and where could I find it in the peer-reviewed literature?
とですね、日本の科学会というのがあるわけですけども、
There is a science academic.
科学会の中で、発表させていただきます。それともう一つ
And so we have made presentation there. And also there is also another academy that is about Japan-US Aging Welfare Society, and the Japan Welfare University has made a presentation. I think these two are the only ones so far.
And many of the university professors that I have dealt with is cooperating with me. And so we are working to write more papers for publication. Many professors are working on it. I'm not that knowledgeable, so I myself am not able to make much presentations. And so I am working with these university professors to be able to announce something.
Thank you again. Could you tell me how fast the reaction is and the quantity of hydrogen? Say, how many kilograms of hydrogen are produced from 1 liter of water, and how quickly? And is it a factor of how much aluminum you add to it? And does the reaction continue until the aluminum is completely transformed to hydroxide?
Here, if normal aluminum reacts, there is a formula. This is the chemically known number. So according to this number, the aluminum reaction based on this formula calculation, 1.245 per kilograms, and per kilogram it's 1.245 liters of hydrogen gas is generated. This top formula shows how this is calculated, how much hydrogen gas can be obtained from aluminum. But with our aluminum, with the reaction per gram, 2.7 liters is obtained. The amount of hydrogen gas obtained is 2.7 liters. This is proven. And with magnesium, 3.3 liters is obtained. And these reactions depends on the amount of water and aluminum, but it takes 2 or 3 hours. And you can continuously obtain the hydrogen during the 2 to 3 hours. And so, depending on the amount of water and aluminum, the 2.7 liters could be 10 times or 20 times larger. And that is adjustable. That's how we feel. However, per gram, you can get 2.7 liters. This ratio will not change. So, and then you multiply that by the amount of aluminum and water used.
The speed of the reaction increases as per the amount of water?
そういうことですね。はい。
Yes, that's right. What we have created so far is a 3 kilowatt fuel cell power generation. And so per minute, about 60 liters of hydrogen is created, and then the power is generated. And this is enough to use in a fuel cell in the eco house. You can turn on the lights inside the house or fill the bathtub. In the performances in exhibitions, we show how the fuel cell can turn on the light bulbs. We've already shown that using this power generation.